Hello, and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 100,000 computing professionals and students who are ACM members. I'm Will Trace, Lockheed Martin Fellow Emeritus and most recent past chair of ACM's SIGSOFT Special Interest Group on Software Engineering, and it's my pleasure to welcome you today. For those of you who may be unfamiliar with ACM or what it has to offer, ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see some of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. ACM provides timely computing information published by ACM, including communications with ACM and Q magazines, access to the ACM Digital Library, the world's most comprehensive database on computing literature, and international conferences that draw leading experts on a broad spectrum of computing topics. Support for education and research, including curriculum development, teacher training, the ACM Turning and ACM Emphasis Foundation Awards, just to mention a few. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. And if I might add, first, Google generously has increased the Turing Award to $1 million. And second, I'd like to point out that ACM membership is really inexpensive. And if you can't afford a full membership, you might look into joining one of the 37 special interest groups where student membership starts at $10 and professional membership starts at $20. Before we get started, I'd like to quickly mention a few housekeeping items shown to you on the slide in front of you. And before we get first, the slides will advance automatically throughout the event. On the bottom panel, you'll find a number of additional widgets and resources. If you are experiencing problems with your slides or audio, press the F8 key in Windows, Command R if you're on the Mac, or just refresh your browser on a mobile device. To control volume, obviously control the master volume on your computer. And more importantly, if you have any questions during the webinar, please type them in the Q&A box and click the Submit button. I will organize the questions as Steve speaks, and he'll reserve time at the end of the presentation to address them. This session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. And as always, check learning.acm.org for updates on this or upcoming webcasts. At the end of the presentation, you will see a survey opened in your browser. Please take a minute to fill it out to help us improve our webinars. You can also use Facebook and Twitter widgets at the bottom of your panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag #ACM Learning. We'll be watching. Today's presentation, Measuring Software Productivity by Steve McConnell, is Measuring Software Productivity by Steve McConnell. Steve is the CEO and Chief Software Engineer at Construct Software, where he consults to a broad range of industries and oversees Construct's consulting and training offerings. Steve is a best-selling author of the industry classic Code Complete, as well as Software Estimation, Demystifying the Black Art, Rapid Development. Steve has served as Editor-in-Chief of IEEE Software Magazine and Chair of IEEE Computer Society's Professional Activities Board. Finally, readers of Software Development Magazine voted Steve one of the 3 most influential people in the software industry, along with Bill Gates and Linus Torvalds. Steve, without further ado, please take it away.
Thank you, Will. Well, it is my pleasure to be here today to talk about measuring software productivity, along with software estimation, software construction, certainly one of my favorite topics. We're going to be going on a little bit of a journey today. What we find is that the ins and outs of measuring software productivity are a little bit complicated, and I think sometimes we try to have a short, 5-minute discussion about measuring productivity, and it's really difficult to communicate all of the important ins and outs of that in a 5-minute discussion, and so it's great to have a little bit of a longer format to discuss these topics. Now, it would be wonderful if our journey looked like the slide with the nice sailboat on the calm water, but unfortunately, I think what we're going to find is that our journey looks a lot more like this picture that you should be seeing of the ship in the stormy seas, and that really is what we're going to find as we talk about measuring productivity, is our journey is going to encounter any number of obstacles, and it would be nice if it weren't really the case, but that really is the case. So let's start by talking about why we would measure productivity, and even to talk about that, I think we need to get into talking about what levels we're measuring productivity at. And the issues are quite different at the different levels. So we can certainly measure productivity at the organization or company level. We could also measure it at the team or work group level. So nominally that would be the 5 to 9 person range. And we could try to talk about measuring productivity at the individual contributor level. So I think it's important in any discussion of productivity to be clear which level we're talking about. Now, from conversations with companies we've worked with over the 20 years we've been in business, what we've heard, reasons that companies would like to measure productivity at the organizational level, are reasons kind of like this. They want to assess competitiveness with other organizations. How do we compare to another company? Very common request. They want to track and evaluate their own progress over time. So no matter how well they're doing now, they want to have some assurance that they're getting better over time and warning if they're not. Some of the reasons to measure productivity at the organizational level are they want to support bonus allocation at the top executive level, possibly even at the CEO level. And then, of course, there's this big question that's been a long-standing question for 15 or 20 years now in the software industry of deciding how to allocate resources to onshore versus offshore versus outsource. And so, as it says on the slide, these are not my reasons. These are reasons given by companies we've worked with over the years who have said they would like to measure productivity at the organizational level. Now, as we turn to the work group level or the team level, the reasons that we've heard are a little bit different. We want to compare teams to see who should be learning from whom. We might want to use it for allocating bonuses across teams. That certainly is a case that comes up. More often, though, we hear companies say they just want to know who's really good and who's not, so who actually stands to improve and who should the rest of the organization be learning from. There certainly is a focus on supporting performance evaluations of the team managers, and again, we see that issue of thinking about allocating work onshore versus offshore just based on the productivity of the different work teams at the work group level. So those are some issues, reasons to measure productivity at the team level. When we get to the individual level, then the reasons that we've heard are things like supporting allocation of people or resources across different teams, contributing information to part of the individual performance review process, and then going along with that would be supporting bonus allocation among individual contributors. Now, I want to be clear. I'm not saying these are reasons I think we should measure productivity. I'm saying these are reasons that our clients have told us over the years that they are interested in measuring productivity. So when we talk about measuring productivity, there are two potential issues that come up that are problematic. And those two issues are, number one, measuring, and number two, productivity. All joking aside, it literally is the case that both of those terms are highly problematic. And so today's journey, I want to talk about the following topics. I want to talk about why measure productivity, which we've really done. I want to talk about what is productivity, which we'll go into next. I want to talk about some ins and outs of an underlying 10x differences in productivity, because that is something that if you've heard other talks by me, you may have heard me talk about before. But when we talk about measuring productivity, that particular issue goes front and center in the discussion. Then we'll talk about evaluating measures of individual and team productivity and see what conclusions we can draw. So turning then to that first topic of what is productivity, there's actually a very simple definition of productivity, which is that productivity equals output divided by input. And this might seem almost insultingly simple, yet an awful lot of the issues that come up related to productivity and that come up related to measuring productivity can be resolved simply by referring back to this definition. In particular, to the importance of being clear what we mean by output and what we mean by input. And if we have errors in either of those terms, output or input, of course that's going to be problematic for our objective of measuring productivity. Now on the output side, this really is the key question in my mind, is that a lot of the things we talk about being outputs are questionable whether they're outputs in economic terms. So is lines of code an output in economic terms, or are function points an output in economic terms? These kinds of things are so far removed from the economics of the business, from the revenue or profitability of the business, it's very difficult to claim that they're actually outputs in any kind of meaningful economic terms. Similarly, is work on a project that ends up being canceled output? Well, you know, that's questionable from a business point of view. It's really more like waste than output. What about work on a project that's delivered successfully but that ultimately fails in the marketplace? Does that count as output? Well, there again, I think it's fairly questionable, or at least we have to consider in our definition of productivity whether projects that don't actually accomplish their intended objective would really qualify as output. So when we talk about candidate outputs, we can look at things like number of product releases. That isn't necessarily successful, but just number of product releases, number of products. We could look at things like revenue and profit. We could possibly look at more detailed items like bug fixes or closed change requests. We could look at hours of uptime or service level attained, support for a company's strategy, which is getting into an entirely different stratosphere in terms of the detail we're talking about, or maybe score on a balanced scorecard. Some other observations about outputs. Most of these measures that I've suggested are impossible to measure at the individual level. We can't really talk about product output or products completed at the individual level. We can't talk about company profitability or accomplishment of corporate strategic objectives at the individual level. So they really are impossible to measure at that level. They're extremely difficult to measure at the team level. If a team is the same team that produces a product, then maybe we could measure number of products released. But again, even figuring out, well, you know, what is the business contribution of that product when we factor in maybe some contributions from marketing and sales and corporate support and so on, that even still becomes difficult to measure at the team level. And a lot of these measurements are actually problematic to measure even at the whole company level, just because of the way the companies are set up and the measures that they do or do not have in place, and even the definitions of what they want to measure. So that's the output side. Well, what we do instead of measuring the things we really care about is that we end up measuring proxies for those things. So we believe that measuring something else will kind of sort of give us an idea of the thing we really want to measure, and that makes our measures of output approximations at best. So moving to the input side, remembering that productivity is output divided by input. On the inputs, the things we hear about companies trying to measure are things like technical staff hours or technical staff cost, which is not exactly the same thing as staff hours for a salaried staff in particular. Business staff hours needed to support the technical staff. Now, the items on the slide with the yellow asterisk are difficult to measure because they tend to be applied across a group, not to individuals. So as we talk about or think in the back of our minds about the ins and outs of measuring individual productivity, we have to be thinking about, yeah, these factors actually contribute and they're difficult or impossible to measure at that level. So business staff hours needed to support the technical staff, such as manager travel time to India, that kind of thing. How on earth do you allocate that to individual staff in a way that doesn't assume the conclusion in the measurement? Investment in travel in general, investment in hardware and other infrastructure, such as communications infrastructure for communication between remote sites. And then what about the delta in technical debt, pre-project versus post-project? For those of us who have been in the technical field very long, we know technical debt's a big deal. The delta where you've significantly added to technical debt over the course of the project ought to be factored in somehow, and yet that's something that we almost never see measured, certainly not in terms of measuring productivity. So some of these inputs seem like maybe they would be easy to measure, but even the easy productivity measures are harder to measure than you think. For example, measuring the number of staff hours applied against a project. You'd think, well, we could have a time accounting system, people track their hours. Well, we talked to one client who was pretty sure that they had completely reliable time accounting data, and they were certain that the input was going to be 100% accurate. But once we got into looking at what their time accounting data actually included, we found that their staff didn't understand why they were collecting the time accounting data. And so because they didn't understand the purpose of it, somebody on the staff had created a script that was used to enter time accounting data the same exact way every day. And this script had been widely circulated across the project and across the organization. And what we found was that the time accounting data in the organization was absolutely worthless. We had projects that had been completed supposedly with around 100 hours, where they had a combined hardware-software environment, and they were creating embedded software. And the idea that you could actually ship a hardware product with 100 hours into the embedded software part of that project is just not a reasonable idea. And they had companion products that were almost identical to the ones with 100 hours that had tens of thousands of hours applied against them. And so really what we found was that the input, the data for time accounting, was just garbage in this organization. And I think that's an extreme case, but you would find less extreme cases in many organizations, but that would equally invalidate the data that you're trying to use as input. So some observations about the simple definition of productivity. When we look at input divided by, or rather output divided by input, it seems like a simple idea at first, but when we really look at the definitions of what goes into defining specifically and accurately input and output, those are problematic. And furthermore, they change depending on what level in the organization you're talking about. They typically change at the individual level, the work group level, team level, business unit level, and the company level. So if you're going to even do this, you have to get clear about what constitutes input and output at each of those levels in the organization. And what we've found is that obtaining business buy-in to these definitions of input and output at any one of these levels is typically a challenging task. Attaining them at all of the levels and then integrating those definitions across the levels is, of course, even more challenging. So where are we on our journey so far? Well, where we are in our journey so far is, in terms of measuring productivity, is that we have not found any great solutions to the problem of even defining what input or what output we want to measure, much less actually measure it. So let's just store that away in the back of our minds for now, that even defining the inputs and the outputs is highly problematic, and let's turn to the topic of measurement. So measurement, if we're going to talk about measurement, then we really have to start the conversation by talking about these underlying 10x differences in productivity. And if you've heard me talk before, you've probably heard me talk about this 10x phenomenon. But I think for purposes of this talk, interestingly enough, the 10x idea originated back in the 1960s in a search for measuring productivity. And we really have to talk about 10x because everything else in measuring software productivity depends on understanding that 10x difference first. So back in 1968, Sackman, Erickson, and Grant conducted a study. And what they were trying to do in 1968 was to obtain data that would allow them to determine whether people's productivity really went up when they programmed online versus programming offline, that is in batch mode. Now, from our perspective in 2016, that's almost a crazy thing to think you need to research, but that really was the topic back in 1968. And what they found as they got into their data was that they weren't able to determine whether productivity was higher in online or offline performance, because what they found was that the individual productivity differences in the programmers they were studying were so large that they drowned out the differences that could be attributed to online versus offline performance. And so, interestingly enough, in their study, they had all their programmers had at least 7 years of experience, but they found the range of initial coding times varied by about 20 to 1. They found the range of what they called debugging times in 1968 to be 25 to 1. Now, I think it's important to note, debugging in 1968 didn't mean what it means today. 1968, the word debugging really meant more what we would refer to as unit test and debugging today. So you might file that away as a note. And then the range of program sizes produced varied by a factor of 5. The range of program execution speeds varied by a factor of 10. And these productivity differences have continued to plague software engineering research really for the last almost 50 years. So this is really significant. And the way the issue plagues research is like this. Suppose that you've got two teams and that one of the teams has higher productivity than the other. So in this example, Team A has higher productivity than Team B. Now suppose, for sake of illustration, that Team A is using pair programming, and suppose that Team B is using formal inspections. So what does that allow you to conclude about which method is better? Well, the really simplistic interpretation of this data would be that pair programming is better because Team A is more productive than Team B. And I say simplistic, but it really is simplistic and overly simplistic at that. Now let's add in the factors that, let's say that Team A actually had star performers on the team and that Team B had average performers on the team. And now, now which method looks better? Well, if we take a look at Team A's normal productivity range, given the fact that they are star performers, and given Team B's normal productivity range, given the fact that they are average performers, now we take a look at where each of those teams was performing within its range, and what conclusion would we draw about pair programming versus formal inspections now? Well, now we would look at it and say that with pair programming, Team A is performing at the bottom end of its normal range, and Team B with formal inspections is performing at the top end of its normal range. So this might lead us to conclude that, in fact, formal inspections are better than pair programming. But what really is valid to conclude is that we just don't know. The differences in productivity are so high, that is to say the differences in individual productivity are so high that it just drowns out the differences in method variation. Typically, we find that variation in individual productivity, I use the phrase 10x as a general shorthand moniker for this variation, but the consensus of the research is actually closer to 20x for differences in individual productivity. And then the research has also found differences in team productivity on the order of 3x to 10x or so. So we have this enormous variation in individual and team productivity, where we look at variation attributable to method productivity, and that might be typically more like something like 20%. And we literally are looking for, well, not literally, we're virtually looking for a needle in a haystack when we're looking at trying to figure out what is the effect of method variation against this backdrop of enormous individual and team productivity variation, just based on capability. So this research result has been replicated many times over the years. It's been replicated enough times that, as far as I can tell, people have just stopped looking at it. It's like, why do we remeasure the constant for the rate at which an object falls, the gravitational force on the Earth? Well, we don't remeasure that constantly because we have a good working number that we've had for a long time. Similarly, we don't have lots of new studies on differences in individual productivity because the research has all gone the same direction, and it's all been pretty conclusive over the years. And there's lots of data available on this, but in general terms, individual variations in individual productivity have been found to be on the order of 10 to 20 to 1. Variations in team productivity have generally been found to be on the order of 3, or 10 to 1, somewhere in that range. So why does all this stuff matter? Well, it matters differently depending on why you want to measure productivity. If you're measuring to assess the impact of a process, a practice, or environmental factor, a method difference, something like that, well, then the measurement will be subject to that confounding factor of the 10x individual variation that we've been talking about. And the measurement of the thing you care about is likely to not be valid. So it's the same case that Sackman, Erickson, and Grant found back in 1968, that their measurement of online versus offline performance was not valid. They couldn't find a way to measure that because of the enormous confounding influence of the individual variation. Now, if you're measuring for a somewhat different reason, let's say that if you're wanting to measure to assess individual or team productivity per se, all things considered, well, now you still find that measurement's going to be confounded by a multitude of process, practice, and environmental differences between the projects. And so even there, then you're going to be trying to figure out, well, what percentage of the variation is due to this myriad of environmental and practice differences, and what percent is really attributable to the actual individuals or the individuals on a team. And either way, we've got so many variables in play that it becomes incredibly problematic to come to any specific or meaningful conclusion based on what we can actually measure. The issues vary a little bit, are a little bit different depending on whether we're in a research or a commercial setting. My focus over the years has really been a lot more on commercial settings, so that really is the focus of most of my talks today. The purposes of measurement are different in the two settings. The different ways that we could measure are different. In commercial settings, we are almost never going to set up two teams doing the exact same thing to measure the differences. There are always going to be lots of differences in the assignments and who's on the team and that kind of thing. But the problem we've been talking about is a problem even in academic research. It's just that the problem becomes more significant in commercial setting because there are more uncontrolled variables that in fact vary from project to project or from measurement to measurement. And so my comments today really do focus on the issues related to measuring productivity in commercial settings. There are other kinds of issues that come up with measuring productivity in research settings, including the idea of it's pretty typical not to get truly representative personnel in those settings. That would be the biggest one in a research or academic setting, is when we find that the individual variation contributes such a high level of variability. If we don't have representative human beings in the academic or research studies, that's a problem in itself. But we're going to focus on commercial measurement for the rest of this talk today. So let's turn now to looking at some measures of individual productivity and seeing, in all this, with all these possible sources of error, are there any measures that might actually work okay? And so what we're going to do is we're going to look at specific measures. I'm going to define some criteria for evaluating or scoring the measures, and then I'm going to present a scorecard that shows how the measures actually stack up according to the criteria that I've defined. So common individual productivity measures, this is at the individual contributor level, really focused on developers. Kinds of measures that people talk about are things like lines of code per staff month or function points per staff month. In an agile setting, we see story points per staff month. And then getting a little bit softer, 360-degree peer evaluations, so evaluations by other people on the same team as the person being evaluated. Evaluation by a manager is one. Task completion predictability, maybe not a very common one, but the idea there is measuring productivity based on how reliably someone completes the task they're assigned when they said they were going to complete them. Test cases passed is another one, or defect counts is another one. And remember, we're typically not measuring the outputs per se, we're measuring proxies for the outputs. So when we get to something like defect counts, we are clearly measuring a proxy. When we're talking about task completion predictability, we're clearly talking about a proxy and so on. Now, in terms of having a good individual productivity measure, I would present the following as criteria for a good individual productivity measure. One is that the measurement needs to truly reflect productivity. And this slide is just here for your reference. If you download a copy of the presentation later, you can pause on this slide and study it. But I'm going to talk about each of these points one by one. So one point is that the measurement truly reflects productivity. We have a lot of examples in the software engineering world of looking for our keys where the light is brightest. The old joke about the drunk who lost his keys down the street, but he's looking for them under the lamppost because that's where the light is brightest. The idea that we measure things because they're easy to measure is certainly something that we are guilty of much of the time in software. Measuring things like time accounting data or lines of code, I think their primary virtue is that they're readily available, not necessarily that they truly reflect productivity. So measurement really should truly reflect productivity, that is, output of high-quality functionality. A second consideration is that the measurement ideally would directly or indirectly account for most or all of the work output. So not just account for coding, but would account for requirements work and design work and test work and team coordination and talking to customers, working with end users, and so on and so on. And a lot of the measures that are proposed account for only a fraction of the work output. Another measure that would be really useful is, or another consideration is, we'd really like to be able to measure the work of non-programmers, which is a little bit related to what I just talked about, but the issues are not 100% the same, as we'll see when we get into the detailed scoring of the different measures. We would like measurement to resist gaming by individual contributors. That is, there's the old saying that what gets measured gets done, and that's often a good thing if we're measuring the right things. But if we're not measuring the right things, then we can inadvertently set up a scheme where people are just gaming the measure and not actually increasing their output. They're just increasing their performance against the measure, and that's not what we want. And I think it's worth dwelling on this a little bit to say this is a really big deal with simplistic measurement approaches. And in general, we can count on work moving from unmeasured activities into measured activities. This actually is a good reason to avoid any kind of single-dimension productivity measures and to focus more on sets of measures rather than individual measures. Another consideration is that ideally the measurement would be strongly correlated with business value created. So recognizing that all the measures we're talking about are proxies to some degree, a proxy that actually more closely follows the business value created is going to be more useful than a proxy that is further removed from the business value created. Of course, ideally, we like our measurement to be objective, repeatable, and independently verifiable. A measurement that varies 50% each time you measure it is not terribly useful, and so we would ideally like that measurement to be repeatable. Also, a measurement that varies based on who's doing the measurement is not terribly useful, and so it should ideally be consistent across numerous measurement attempts and based on who's measuring it and so on. We would like the measures to measure output the same regardless of the programming language used, and this is the big challenge with lines of code, is that the amount of functionality varies tremendously per line of code depending on what programming language we're looking at. And the slide shows examples of the lines of code per function point, so the number of lines of code required to implement one function point. And we can easily get factors of 2 or 3 or 4 difference in our measurements based on when we use lines of code that would indicate different levels of functionality output if we're not careful to account for the difference in language level of the languages that we're using. We would really like our measurement to support comparisons across project, and the real issue there is a measurement like story points where each team defines its system of measure locally, and if that's done, then it becomes very problematic to try to compare productivity across different projects. So all things being equal, we'd like to have a measure that supports cross-project comparisons. And the last really substantive point is that we'd really like to account for this issue of the best people getting the most difficult assignments. And this is a measurement challenge that plagues all kinds of measurement, not just in software. We see discussions about this issue in medicine where we talk about cure rates for doctors and hospitals and so on that can be confounded by the fact that the best doctors get the patients who are in the worst shape, and some hospitals specialize in treating very sick patients, and so their cure rates don't look as good if you look at it superficially, but actually they're recognized as the best even though they have the worst cure rates. We see the same discussion in education where we find systems of teacher evaluation that don't account for which kids different teachers get, which can be something that varies by classroom, but also something that varies by school and by school district. And so in software we have the same issue where we have to account, the measure ideally would account for the best for which people, or for the level of difficulty in the assignments that people are getting, and the fact that often you give your hardest task to your best staff. And then all other things being equal, it'd really be nice if the data could be collected easily and cheaply. I don't think that's really that's a super deciding factor, but as a tiebreaker, that could certainly be a good tiebreaker. So what I've done in terms of evaluating the measures against these criteria is that I've set up a scale of 1 to 5, where 1 means that the measure does terrible against the criteria, 2 means the measure does badly, 3 is it's neutral, 4 means the measure does well, 5 means it's excellent. And I will certainly concede that the following scoring I'm going to show you is subjective, but it does have the advantage that it's explicit, it's written down, you can look at it, you can study it, you can argue with it, you can actually refine it and improve it. And it's also structured, so we have some idea of what we're actually trying to accomplish, and we're applying the same criteria to all these different candidate productivity measures, and so that's what we're going to do. So let's take a look at numeric ranking of these individual developer productivity measures. And again, this is a little bit hard to look at in a live presentation. If you take a look at this presentation after it's released and can pause on this slide, that might be an easier way to really study this. But what we've got is we've got all the criteria listed down the left side, and we've got all the candidate measures listed across the top, and then we've got my scoring of each of those measures against each of their criteria in the cells in this spreadsheet. And we could probably have a conversation that lasted half a day or a day going through the scoring in those cells. Personally, I would be happy to do that because it's an interesting topic. But for purposes of the conversation today, let's just take a look at the average scores, that bold row, second from the bottom. And I will note that the range of scores ranges from 2.5 for lines of code per staff month up to 4.1 for test cases passed. And then please also note that we've got about several answers that are in the 3.7 to 3.9 range. So a pretty tight cluster of points or of measures all clustered in that 3.7 to 3.9 range. And I don't know that given the input here, the garbage in, garbage out principle applies to some degree, and so I think those are essentially tied. So I think what we've got essentially is we've got test cases passed in first place. We've got what is essentially a 5-way tie for second place, and then we've got lines of code per staff month in last place. And let's take a look at some comments on those. So I think it's worth pointing out that lines of code per staff month is easily the worst measure. Lines of code per staff month has certainly been criticized vigorously over the years. And I think putting it against this kind of scoring table starts to tell you why. It doesn't really perform that well, and there are lots of reasons that it doesn't perform very well. And so I think it's been criticized, and there are some good reasons for that. Interestingly enough, let's see. Interestingly enough, there's no measure that does better than 4.1 on a 5-point scale. I think that's worth dwelling on. So none of them are super fantastic. 4.1 is actually, I think, a mediocre score. And then, of course, we've got the top 6 measures that are closely ranked, 3.7 to 4.1. We could either call that a 6-way tie, or we could call it a 5-way tie for second place. I think that, interestingly enough, the very top one, test cases passed, it does well because it resists gaming if you have independent testing. But if you're in a more, if you're in an agile development context where developers are writing their own test cases, then it doesn't resist gaming as much, and then it drops to 3.9. That is to say, it moves into a 6-way tie for first place. So, in my mind, it's quite interesting that manager evaluation does better than you might expect as a, quote, measure. It actually has the best effort rating of anything in the set, and it's actually the most readily available. And so my conclusion on this is actually, as you can see on the slide, is kind of a sunny day conclusion. And that is that when you really score the different ways of measuring productivity, it's possible that this idea of actually measuring productivity is the proverbial solution in search of a problem. That there's no actual business problem here that needs to be addressed, that we find that we have an existing technique, which is manager evaluation, that stacks up very favorably against these other measures, and certainly when we throw in the consideration of the incredible error that we get in the measures due to the difficulties in measuring the input, the difficulties in defining the input precisely, defining the output precisely, and then, of course, the whole individual productivity confounding factor, it's quite possible that actually this non-measurement technique of manager evaluation is, in fact, the right answer to this measurement question. So I find that fascinating. All right, so that's it for individual productivity measurements. Let's talk briefly about evaluating measures of team productivity. And we're going to go through a similar process here. It's interesting on this picture. We've got the sunken ship, and we've got dolphins circling the sunken ship. I think maybe more accurately we would have sharks circling the sunken ship on the measurement topic. But let's talk about the measures. So the measures are for measuring team productivity are quite similar. We've still got lines of code per staff month, function points per staff month, and so on. But we've got a couple measures that have changed somewhat. Instead of individual manager evaluation, we've got manager stack rank evaluations, which would be a more common kind of a team level or measurement. We've got, instead of reliability of individual task completion, we've got project completion predictability, and then we've added a measure of a scorecard. And so that's kind of interesting in itself, a scorecard. So the top level considerations are similar for evaluating these measures, but they're not identical. If we take a look at the items that have asterisks on them, we certainly think the measure should be useful for measuring the work of the whole team. Directly or indirectly, it should resist gaming by the team, which is not exactly the same thing as resisting gaming by individuals one by one. It should be strongly correlated with business value created, not just with output or functionality, but with business value created. It should accurately reflect the output of teams working on diverse kinds of projects. So we have the same issue. Sometimes the best teams will get the most challenging assignments, but sometimes we just have teams working on vastly different kinds of software. So one team might be working on a front-end system where they can generate tons of lines of code. Another team might be working on embedded real-time safety-critical systems where they're not going to be generating the same quantity of code that a team working on a low reliability a business system might be working on. So there are some differences between the individual measures, and there are some things that are the same. All right, so let's take a look at the results. And here again, this might be more useful if you could actually pause this, and so that might be something to do at a later date. But what we find is that we don't have a whole lot of difference from what we had before. Lines of code still performs the worst. But this new entry of the scorecard actually performs pretty well. In fact, it performs notably better than any of the other options. And so let's kind of talk about what we see on this a little bit more detail. Interestingly enough, we still have 5 measures that are closely ranked that essentially constitute a 5-way tie for second place. The big difference between individual ratings that, in terms of things that carried forward from the individual rating, is that test cases passed is a lot more susceptible to gaming at the team level than it is at the individual level, and so it doesn't stand out at the team level quite as much as it did at the individual level. Since the scorecard performed the best, I thought it would be a good idea to show an example of what I mean by a scorecard. So this is by no means canonical. It's just an example. It could be varied tremendously from organization to organization, but just to make sure people understand what I'm trying to describe here, it can include things like a score for on-time delivery, score for initial defect rate, a score for the defect rate 90 days post-delivery. We could have a score for the percent of planned functionality delivered. We could have a score for the teams notifying the rest of the company about problems early, so early notification of problems. And then we could have some somewhat subjective elements on the scorecard, the executive satisfaction with project execution and delivery, and sales satisfaction with project execution and delivery. One of the really strong points of this kind of approach is we can structure the scorecard so that it resists over-optimization against simplistic measures. We can actually construct it so that if the team actually tries to optimize against the items on the scorecard, that's a good thing because we get what we want. And if we're not getting what we want, then that's a problem with the scorecard, and we should revise the scorecard so that if the team actually tries to game the scorecard, that actually will give us what we want, whether they're trying to game it or whether they're doing it out of good intent. So, is the scorecard a panacea? Well, it's not exactly a panacea. There are some issues with how independently verifiable it is, but it is structured. We put out there what the criteria are. We put out there how many points they're worth. It does avoid over-optimization for any one measure. It can be used to provide cross-project comparisons if we use the same scorecard for every project, and it can be made public and it can be reviewed. So if there is some gaming, that can come up during the review. If if 2 different people have created 2 different scorecards and they're not really using the same standard for the entries in the scorecard, well, that can be made public and reviewed, and then it can be normalized through discussions and so on. And then finally, the scorecard can and should be tailored to support organizational goals so that if a team performs well against the scorecard, it is in fact contributing to the organization in a way that really would contribute output that supports the strategic objectives of the organization. And so as such, I think it really is, it is a very strong measure in this context. So we've covered a fair amount of ground in our journey on software measurement. I think we've reached a fairly satisfying place, as it shows on the slide. That's been a little bit stormy and we've encountered some difficulties, but I think that we've come to a conclusion that actually is okay. In terms of the measurement topic per se, I think we do find that measures are significantly limited because agreeing on the definition of productivity is problematic, particularly agreeing on meaningful outputs. Coming up with ways to meaningfully measure those outputs can be super problematic, and even when we do, we're often measuring proxies rather than the thing we really care about. We find the inputs are also subject to significant measurement error, and I think you have to keep in mind that the entire measurement exercise is subject to this massive measurement error due to the 10x variation phenomenon. And so when we're talking about numeric measures that we're trying to extract out of the product, or out of the project, out of the people on the project, then all of these issues are in play, and we can't just ignore them or say, yeah, but what about this? We have to start by figuring out what are we going to do to solve these kinds of problems before we talk about real numeric measures. And the good news here, though, is that the questions that businesses want to address through measuring productivity actually can be addressed effectively through non-measurement or quasi-measurement approaches. And when we actually score these alternatives using a structured approach like the evaluation rubric that I gave, it turns out that these alternative approaches actually stack up very favorably versus measurement, especially if you fully account for the limitations that you find in true measurement. And so I think we actually end up in a fairly good place when all the dust settles. We end up where we can solve the problem we want to solve. Maybe we just don't quite solve it the way we thought we were going to solve it, but we have quite a satisfactory solution nonetheless. At this point, I will turn the microphone back over to Will and see if we have any questions.
Oh, yes, we do have plenty of questions. And first, I'd like to thank the attendees for those thoughtful questions. And let me make an observation in the productivity factor here that the last 10 just came in the last minute. So we have an exponential growth in those questions. I'll try to take them in sort of the order that they were given because there seem to be many questions having to do with technical debt and whether it was a candidate for input rather than output, and can you explain with an example?
So the question is technical debt a candidate as an input? I would say no. I don't think technical debt is an input in the sense that I have defined it. The input is basically money or staff effort or staff time or something like that. It's to measure productivity, the input has to be some sort of economic input. And I don't think technical debt is an input. I think that technical debt could conceivably be part of the output. In other words, if you were to measure the reduction in technical debt, that would constitute work. And so counting the reduction in technical debt as some of the work or output of the project, I think could be a valid thing to talk about. But I think then I would just add it to the list of other kinds of output that are pretty far removed from the outputs that at the end of the day the business really cares about. So if at the end of the day the business cares about successful product releases or cares about revenue or profit, then that connection between reducing technical debt and successful product release or revenue or profit, there's a connection there, but it's a pretty indirect connection, and it's more of a long-term connection that has an effect over time, maybe on multiple product releases, not just one product release. So I think as a component that would be used to measure productivity, I guess at first glance, I don't see a lot of additional contribution from the technical debt. Okay.
There's a topic of quality. Where does quality come in the measurements? The quality of the output as well as the quality of the measurements.
So where does quality come in terms of quality of the output, quality of the measurement? Well, the scoring table that I put together is very much intended to be the quality of, or intended to score or evaluate the quality of the measurement. So, or at least the kind of measurement. So I think that was the intent. And can you repeat the first part of the question?
The question was just, where does quality come in? And I mean, I interpret the question as one of those gaming the systems, because you could be very productive based on whatever measurement you were being judged against, but then down the road, the results are going to be less than, long-term impact is less than desirable. And let me just add an additional question here because it is relevant, and the question was stated, productivity and measuring also are impacted by the time window of a data set used. For example, if I'm a programmer developing a framework, my initial productivity is really low, yet on the long term, if my framework is useful, I can get better productivity.
Yeah, so I mean, the whole question, though, is at a level of detail that the business may or may not care about. And so, yeah, if you're a programmer and you invest time in developing a framework and it slows you down for the first 3 months and it speeds you up for the next 2 years, then, you know, in terms of measuring productivity, you know, what am I going to measure to actually find that productivity? That's really the question. I mean, I think that question, the technical debt question, the quality question, none of those are really about measures. They're all about influences on productivity, not really about measuring productivity. And so so the question really goes back to the main point of the talk, which is, how do you put a measure in place that would tell you whether that work on the framework actually was truly productive in the long run, or wasn't it, right? So the question kind of assumes that it is going to be productive, but that's not really the point of this talk. The point of this talk is measuring the productivity so you can determine whether that actually was productive or not. And same thing with quality. You know, quality, there are a fairly limited number of contexts where quality matters absolutely, where we've got safety critical or life critical systems. There are many, 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 many more contexts where quality is really a means to an end, which is it's a means to customer satisfaction, and it has to, or means to product appeal, or maybe even a means to efficiency in producing the product. And so we have to balance our pursuit of quality against other factors. And this is one of the reasons I think that organizations would like to have measures of productivity is, you know, I've written extensively about the idea that up to a point, pursuing quality supports efficiency and supports short schedules and so on. And, you know, we've got some nominal ideas of where that point is, but do we have a really exact idea in any particular company? You know, that's going to be an exercise in approximation on the ground in real companies. And so, you know, ideally we would have some way to draw the line and measure, you know, when is enough enough. And I think that's part of the motivation for companies wanting to actually measure productivity.
Now I have a meta question, and I say that, and after I state it, you'll get the idea why I phrased it this way. Do we have an evaluation of the cost, or a productivity measure, an efficiency measure, of the productivity measuring procedures? So in a nutshell, what is the efficiency of productivity measurement?
Yeah, so basically what's the return on investment, what's the ROI on productivity measurement itself? I think that's a valid question. That's why my last consideration in the scoring rubric was all other things being equal, lower cost to measure is better than a high cost to measure. I also think that, so that's kind of I think it's a valid consideration. On the other hand, I think that consideration causes us to end up having the tail wagging the dog in terms of what we see on the ground with companies, where companies will say, well, we already have lines of code and we already have time accounting data, so let's measure productivity using those two readily available pieces of data. It's like, but neither of them mean what you think they mean. And so when the companies start to look at, yeah, but what does it really cost to get meaningful data on the economic inputs and the economic outputs, I think once companies understand that, they actually are a lot less interested in measuring productivity. So, yeah, I mean, in terms of the meta question, I think what you see is that there may be a little bit of a wisdom of crowds phenomenon here, where companies talk about measuring productivity, but what they end up doing on the ground is they use manager evaluations or 360-degree peer evaluations for performance review, which pretty holistically, obviously that's subject to bias and that kind of thing, but it at least conceptually has the potential to include holistically everything that you need to be considering in terms of not just lines of code produced, but could account for quality of lines of code produced, reliability, working within the team, contributing to the productivity of other team members through good teamwork and factors like that. And so, I think that while we hear lots of lip service paid to measuring productivity, on the ground what we really see is manager evaluations and informal or possibly structured evaluations of teams through manager stack ranking of teams, or in some cases, not as many as there should be, I think, but in some cases use of some kind of a scorecard. So interestingly enough, I think maybe what's really happening on the ground makes more sense than what people talk about wanting to do.
Good. Now, there's been several questions about academic research. Could you advise that, is there any particular topics that are worthwhile, PhD dissertation or a case study, and exploring from an academic perspective?
It's been a while. I like that question, and it's been a while since anybody has updated, at least that I've seen, anybody's updated differences in individual programming productivity. And we have had some assertions the last few years from people who basically say, well, on Agile teams, everybody cooperates so much and there's so much collaboration, it really reduces the variation in individuals. Well, that's not what we've seen, but apparently some people have seen that somewhere. It would be very interesting to get an update on that research. I think I think the differences are not due to Agile versus waterfall practices. I think the differences are due to human beings being human beings, and there have been some studies that have found that you see comparable differences in other fields, where the 80-20 rule applies. And 20% of the police detectives make 80% of the arrests, or 20% of the NFL quarterbacks make 80% of the touchdown passes, or 20% of the authors write 80% of the bestsellers, that kind of thing. And so the idea, really, what we're seeing in software is that this fundamental human dynamic applies in software just as it does everywhere else. Really, all we're saying is software is not the exception to the rule. But I think a lot of people in software are so concerned about things that are new and recent that I think having a new update on that data could be useful, even if it finds the same thing that has been found many times before. It'd be nice to have that with a 2016 or 2017 date stamp on it, as opposed to a 1968 date stamp.
Okay, we're slowly running out of time, but I have three good questions that I think I'd like to finish with. But with that said, to the attendees, please keep the questions coming, because we may have the opportunity to answer them at a later date. With that said, the very first question that came in was, how does the variability in software productivity compare to productivity variability in other engineering fields?
In other engineering fields, I do not know. I kind of gave I gave the answer to that question I would have given just a moment ago, which is that we've seen studies of variation in other non-engineering fields that have found there's lots and lots of variation. So I don't know. I could only speculate about other engineering fields, but I would apply that general observation that people just have different capabilities. They have different levels of native capability. They have different levels of motivation. They have different levels of ability to concentrate on specific project work at any given point in time. So the idea that that wouldn't be true in other engineering disciplines seems extremely unlikely to me, but that's the best answer I could give.
Okay, thank you. Here are two questions. Has productivity improved over the years? Are we going forward? And I'm going to couple that with a question that says, can you discuss any personal improvement measures that a developer might do for his or her own personal edification? What techniques might the developer use to measure his or her personal growth? Is that relevant?
Yeah. Well, there are some extremely disciplined and detailed frameworks at the individual developer level. Watts Humphrey's Discipline for Software Engineering and his personal software process come immediately to mind on that topic. And if you really want to measure your own performance and you're really committed to doing that, then getting into PSP, I think there's actually really good data on PSP that says that it will pay off. The challenge with PSP is it's such a high discipline practice that very few people actually stay with it over time. So while the data on it's really, really compelling, that doesn't seem to be compelling enough to get people to actually stick with it. So, there are ways to measure your individual productivity if you're willing to put in the work. I guess it actually is almost the same answer as the question earlier about what's the ROI for organizations measuring productivity. When you really look at what's involved in coming up with a meaningful measure, it becomes difficult for most people to justify the effort that goes into making that happen. So the other part of that question was, do I think productivity has improved over time? I think if you take a really long view of it, the way I would answer that question is by saying, I think there are categories of problems that don't exist anymore that did exist when I entered the field 30 years ago. And to the degree that whole categories of problems have gone away, to me that does say that productivity has improved. At the time I entered the field, integration failure was a common issue. You'd have teams developing pieces of software separately and then trying to bring them together at the end of the project in what was known as Big Bang integration. And it was pretty common at that point in time for projects to fail during the so-called integration phase, because it actually was a phase at the end of the project. And we really don't hear about that much anymore. I think at least in software, pure software systems, everything is so incremental now that we don't really have a notion of integration failure anymore. So one of the more common sources of failure is just gone. We've spent a lot of time over the last 30 years talking about prima donna programmers and the challenges that come up with people who are just really difficult to work with. But I think that the widespread adoption of Scrum, when it's done in a high fidelity way, it doesn't turn everybody into a ray of sunshine, but it actually goes a long way toward eliminating that problem of somebody who goes into a room and stays there for 2 months and may or may not ever actually come out with anything. The openness of and accountability of having to stand up every day in your daily stand-up and say, here's what I got done yesterday, here's what I'm working on today, and here's what I need help with. That kind of forces the issue. Those people either get on board and they become productive members of the team, or they leave. And so that issue, we've seen many organizations now where that issue doesn't really exist anymore. So, bit by bit, I think we see issues just kind of going away, and so that makes me think that productivity is in fact getting better. Certainly the expressive power of the languages that people are using now compared to when I started in the field using Fortran and Pascal and GW Basic. The expressive power of the languages today really should be getting a lot more functionality per line of code. So I think there are a lot. I certainly couldn't even begin to put a number on it, but I definitely think there have been improvements in productivity.
Well, I think we've run out of time, and I really wish we had more time because there are a lot of interesting questions that I wish I had time to ask. But with that, I'd like to thank Steve again for his informative presentation and insightful answers to the many questions. And a special thanks to each of you for taking the time to attend and participate today. This webinar was recorded and will be available online in a few days at learning.acm.org/webinar. You can find announcements of upcoming webinars and other ACM activities at learning.acm.org and acm.org. And please fill out the quick survey where you can suggest future topics or speakers which you would like to see what's on your screen now. On behalf of ACM, Steve McConnell and myself, Will Trace, thanks again for joining us, and we hope you will join us again in the future. This concludes today's webinar.